So we'll be starting with a new chapter, right?
No, it's the same one. In motion only we have a topic acceleration.
Okay.
Okay. So first of all, we will start with uniform motion and non-uniform motion. So let us see what is uniform motion. If an object moves with a constant speed, so that we call as the uniform motion. But uniform motion can be defined in other terms. The terms are different. So uniform motion and non-uniform motion. The uniform motion, just the meaning is the same, that if the object moves with a constant speed, that will be the uniform motion. But the words are that if an object or if a body travel equal distances in equal intervals of time. Okay. So if an object travels equal distances in equal intervals of time, it is said to have uniform motion. It is said to have uniform motion, right? So see how we say uniform it is, and in this it means that it is moving with a constant speed. The speed is not changing. Okay. Also, I request all of you to turn on your cameras. So please turn on your cameras, all of you. So consider an object moving here. So you have, let this be the object which is moving, and we are constantly recording it for a certain period of time. So however small the time interval may be, you can take the however small time intervals, but it will be traveling equal distances in equal intervals of time. Suppose there is a journey of, let's say you have a journey of 100 meter. So for a journey of 100 meter, if an object starts, so let's say in the first second, in these are the seconds, uh, we have 2, 4, 6, 8, and 10. So here I am marking the time. Rohit, Pranav, Pranav, are you there?
Yes, sir.
So please, Rohit and Pranav, turn on your cameras. So here we have the time in second. Okay. Suppose the object is traveling the distance of 100 meter. We observe it for first 2 seconds. So in the first 2 seconds, if the object travels a distance of 20 meter, in the next 2 seconds, it again travels a distance of 20 meter. In the next 2 seconds, it again travels a distance of 20 meter. So on. So every 2 seconds, it travels a distance of 20 meter. Okay. And every second, it is traveling a distance of 10 meter. So such a motion will be called as a uniform motion. However small time interval you can take. But if you take equal intervals of time, so it will travel equal distances. An object will travel equal distances in equal intervals of time. This we will call as the uniform motion. In the case of non-uniform motion, the things will be a little bit different, something like this. So for the non-uniform motion, Again, we have the object and it is traveling a distance of 100 meters. Let's say the object travels a total distance of 100 meters only. And again, we have the time intervals here 2 seconds. This is 0 second. 2, you have 4, then you have 6, then 8, and then 10. So suppose in the first 2 seconds, the object travels only 2 meters. In the next 2 seconds, it travels a distance of 4 meters. In the next 2 seconds, it travels a distance of 6 meters. In the next 2 seconds, it travels a distance of 10 meters. In the next 2 seconds, it may travel the remaining distance. Okay. Suppose in the next 2 seconds, it travels a distance of 28 meters. Now, here we observe that the object is not traveling equal distances in equal interval of time. So such a motion will be called as a non-uniform motion. Okay. So this motion is a non-uniform motion. Okay. So in the non-uniform motion, the speed of the object is changing. Whereas in the uniform motion, the speed does not change. Any doubt to anyone? Okay. So if an object covers unequal distances in equal intervals of time, that will be a non-uniform motion. Okay. Now, if we look at around us, the objects moving around us, where do we find a uniform motion? Yes. Can you give me any examples of uniform motion? Yes, Beta, can you give any example of uniform motion? Anyone can give any examples of?
Sir, will it be like the car traveling?
Okay, if a car travels on a straight highway with a constant speed, so that would be a uniform motion. A car traveling on a state highway with a constant speed of 60 km per hour or 40 km per hour, whatever, that would be uniform motion. Okay. Similarly, an aeroplane flying at a certain height with constant speed, that would also be an uniform motion. What about a car moving through a traffic? Yes. If you observe a car moving through a traffic, so what type of motion does it possess? Does it possess a uniform motion or a non-uniform motion? Yes, Rohit, what type of motion will be possessed by a car moving through a traffic? Crowded traffic? Rohit? Harshit? Rohit and
Yes, sir.
Harshit? Yeah. So what would be the motion of a car moving through a traffic? A car moving through a crowded market.
Sir, can you repeat?
A car moving through a market is a crowded market is an
Uh,
example of uniform or non-uniform.
Sir, non-uniform motion.
Non-uniform. Then what about a ball being dropped from a certain height? Yes. Any examples?
Sir, it could be uniform motion.
Okay, see, the next one, we observe here a ball being dropped from a certain height. Dropped from a certain height. So is this motion a uniform motion or non-uniform? Yes, is it uniform or non-uniform?
Sir, is it non-uniform?
A ball dropped from a certain height, a stone thrown vertically upward, both are examples of non-uniform motion, right? As in this case, we observe the speed of the ball changes. The speed of the ball is not constant. Okay. So the speed of the ball changes. We call such things as the non-uniform motion. So this is
Sir, so a ball which is rolling on the floor is also non-motion, right?
yeah, that is also non-uniform motion since there is friction, and because of the friction, the speed of the ball is changing. Okay, so that is a non-uniform motion. However, if the ball moves with a constant speed, so that would be a uniform motion. So, but here I will be talking something special about this ball and the stone. Okay, see, if the ball is being dropped, there is a difference between a ball being dropped and a car traveling. What was the difference? Here we have a ball which is dropped, and the ball is dropped from a certain height. So when the ball hits the ground, it hits the ground with a certain speed. The ball is at a certain height. So when we are holding the ball in our hand, it does not have any speed. Its speed is zero. So at this point, its initial speed or initial velocity is zero. When we are holding the ball in our hand, the initial velocity of the ball is zero. And when the
Sir,
ball
but
touches,
won't it be in constant speed while it's falling down?
no, while it falls down, when it is in your hand, its speed is zero. When you drop it, so as the ball comes down, its speed increases.
Okay, sir.
Okay. So when you catch, it hits the ball with the highest speed. So the speed of the ball changes here. So it is an example of non-uniform motion. But here we observe one thing, that speed is constantly increasing, right? Whereas a car moving through a traffic, it's something like sometimes its speed is increasing, sometimes decreasing, sometimes increasing. So that is a different case. That is also a non-uniform motion. This one is also non-uniform motion. But to this case, we will be calling it as uniformly accelerated motion. This is our uniformly accelerated motion. We have here, in this case, in the case of uniformly accelerated motion, the speed of the object either increases or decreases at a constant rate. Understood this? Understood the definitions?
Yes, sir.
Okay, so such a motion will be called as accelerated. Now we define two other terms, that is velocity and speed. So we'll be doing the differences between speed and velocity.
Same.
Okay, so let's say speed and velocity. Okay. So what generally we use these terms interchangeably, but in physics both of them they are different from each other. Okay. We see that speed is a scalar quantity. Okay. So speed is a scalar quantity, whereas velocity is a vector quantity. So how the speed and velocity are defined? See, speed is defined as the rate at which the object travels the distance. So we write speed as distance by time. The formula for speed is distance by time, but velocity is defined as displacement per unit time. So how fast the displacements are covered. It is displacement per unit time. How fast you cover the displacement, that is your velocity. So there is a difference between them, as we know that the distance and displacement are two different things. So speed and velocity are also different. You can call this velocity to be speed with direction. Okay. So if the motion is in a straight line, or we can also call the speed with direction, is speed direction. Since velocity is a vector quantity, you have to provide the direction in which the velocity is, or the direction in which the object is moving. That we will call as the velocity. Got it? Got it? What is velocity? Okay. So here I will give you a small question to understand the difference between speed and velocity. We'll do a small question just to understand the difference between speed and velocity. So here you have the question. A boy travels 200 meters in 15 seconds. Then he turns back and travels a distance of 100 meters in 5 seconds. Find his speed and velocity. Hmm? Find H, average speed and velocity. Okay. So find H, average speed and velocity. Now, so will you be able to solve it on your own? Yes, Rohit and Pranav, will you be able to solve this on your own? Anyone who will be able to solve it?
So the total distance should be 300.
Mhm. Total distance would be 300 meter.
So then average speed will be 300 by 15.
No, 300 by 20.
Oh, yes, 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 15 to 15. Yes.
Okay. So average speed,
So then the average speed will be 15.
300 by 20, that is 15 meter per second.
Yes, sir.
And what should be the average velocity?
So, so 15 by so I wasn't able to solve this part.
So average velocity, it's given by displacement by time. So what
Yes,
is
sir.
the displacement?
So displacement 100.
Yes, displacement is 100 meter and time is 20 seconds. So 100 by 20,
So
that is
5.
just 5 meter per second. So now this is your velocity. So I hope you have understood the differences between speed and velocity.
Yes, sir.
Now, what can you say about the speed and velocity if the object moves in a straight line without turning back?
So then average speed and velocity will be equal.
Yes. So average speed and average velocity both will be equal to each other, right? So this is a very important point. We can note it down. So if an object moves in a straight line, then speed and velocity are same, are equal. Okay. I hope all of you have got this.
Yes, sir.
Okay. So now we move towards acceleration. So acceleration, shall we do it right now? Acceleration. Okay. So let us see acceleration. So we define acceleration as the rate of change of velocity per unit time. Acceleration is rate of change of velocity per unit time. The acceleration is rate of change of velocity per unit time. That means how fast the velocity is changing with respect to time. For example, if we consider the case of ball falling down, So again, let us consider the example of ball falling down and we'll find out the acceleration. So you have your ball falls down. Okay. Now, if you observe this complete case, in the beginning, here, the ball has a certain, when the ball is dropped, it's not moving. When the ball is in our hands, it's not moving. So at this point of time, its velocity is zero. Okay. So we call it as the initial velocity. So initial velocity means the velocity at the starting of a journey. This is another definition. Initial velocity is the velocity at the starting of a journey. So when a journey starts, then whatever velocity is possessed by the object, we call that velocity to be the initial velocity and it's represented by the symbol u. Then we have another term, the final velocity. So final velocity, it is the velocity at the end of a journey.
What
So
is
the velocity,
initial velocity represented by?
yes, velocity is represented by the symbol u and the final velocity is represented by the symbol v. Okay. As v comes after u. Okay. So u will be the initial velocity, v will be the final velocity. Right? Also do remember that the SI unit of velocity is meter per second. It's meter per second. So now we will write the formula of acceleration. See the acceleration, it's defined as rate of change of velocity per unit time. So we'll write it as acceleration A equal to change of velocity per unit time. It should be change of velocity by time and hence we'll write it as v minus u, which is the change of velocity and divided by time. Okay. So I'll give you just a small question regarding this acceleration. I hope you will be able to find it. Shall we start? Keep a note of the formula that acceleration is given by, keep a note, acceleration would be equal to v minus u by t. U. So do keep this formula, then we start with this question. Let's see. It's the ground with a speed of 19.6 meter per second in 2 minutes. In 2 seconds, sorry. Find the acceleration. So who will tell the answer? Yes, find the acceleration. Will you do this right now or as a homework?
Sir, will it be like this acceleration is equal to 19.6 minus, sir, I'm not able to guess the
Initial speed,
uniform speed, sir.
not uniform, initial.
Yes, sir.
See, initially it was in our hands. It was dropped. So its initial velocity should be 0.
Sir,
Okay.
is the answer 9.8?
Yes, the answer is 9.8 meter per second. You will get your answer acceleration as v minus u over t.
Sir,
V
so
is
initial speed is always 0.
It's not necessary. You have to observe the case and then we'll do. Okay. So for
Yes,
this case,
I understood.
you will get
So 9.8.
9.8 meter per second square. Okay, student. So bye everyone. We'll continue with this in the next class.
Sir, can you post all the PPTs of what we have done till now?
Yeah, everything is available over there in the Y app.
Okay, sir.
Okay, bye.
Thank you, sir. Bye, sir.
Bye.
Thank you, sir.